Hello everyone, this is our second lecture. In today's video, you're going to learn how to use R. It's an introduction. So you have two alternatives. You can, work locally on your desktop. You can download the R software from the R project. So you just Google it, R, and you will get the first link to, to access to the base package. If you want, it's possible also to install RStudio, which has a better interface. But at the end, it's the same thing, right? So you can install R and RStudio on your computer and your laptop, so you can work locally. That's one alternative. Now, in this course, we're going to use Colab, Google Colab. The good thing about Colab is like it's online, it's flexible, it's easy to use, and it also has a artificial intelligence, generative artificial intelligence. So at some point, if you're stuck with your code, you can get help. All right, so I'm gonna go to Colab. You need to log in. So just create a new notebook. It's gonna be an empty notebook. That's it. All right. So this is what you should get initially. I'm gonna wait a little bit. The idea is like you work with me at the same time. Let me zoom a little bit, zoom in. All right, so the default here is that Colab is gonna try to use Python to analyze your code. But in this case, we don't wanna use Python. The idea for us is to use R initially. So if you go here to runtime, you click change runtime type. So if you notice, the default here is Python 3. You just change it to R. And that's it. Now you can use R code here. It's as simple as that. Okay. So you can add two types of blocks. You have code and text. Let me show you the text. So here you can type anything that you want, and you will get the result. But of course, you want to organize a little bit your notebook, so you can use some titles. So you can do like lap 1, and this is how it looks. The two options to at the right, you will see how it looks. Please note that this is a title because I use the hash sign. So if you click, outside the box, you will see how it looks. You can also, if you have like two hash signs, you have subtitles. And of course, you can start typing other type of information. So this is just text. This is just text, especially if you want to describe, maybe add like a title, your name, some information about the activity. So you can use the text block. It's easy to use, and there are a lot of things that you can do. So here, for example, if you want to add more text, so this is normal text, but if you want, you can go with italics. So you need to add so now you have italics, and if you want bold font, so you have two multiplication signs, and that's how you get the boldface right there. So that's just for text, but also it has nice options, especially if you're trying to maybe write like a fancy equation, especially in the class. At some point, this is like even though it's data analytics, we talk a lot about statistics. So maybe sometimes you wanna, like type an equation. So here you can use LaTeX. So if you wanna add an equation, you can use the dollar sign. And let's say it's a function fx that is equal, I don't know, let's say 5x plus 3 alpha, I don't know. So this is how it looks. So it's nice, it's nice. This is LaTeX. So you will get like really good equations, even better than Word, if you ask me. The quality and the complexity of the equations that you can type here, it's good. So this is just LaTeX. This is just LaTeX. On top of that, by the way, this is not R. What I'm teaching right now is just to do your documents better. Maybe your reports, if you want to make them look good. You can also have a list here. For a list, it's simple, just with the dash. So it's like number 1, this is the text. Number 2, or you can enumerate like 1 to get a numbered list. So this is the item 1, item 2, and again it will recognize that it's like bullets or a numbered list. So it's simple to it's very intuitive to type text here in these text blocks that we have. All right, so now let's go to the coding part, which I guess that's what you want to learn here. Okay, so let's go with the basics. R, it's a programming language, so you can just create variables like x equal to 5, for example, y equal to 10. We can operate those variables, like the multiplication of them, x times y, and we can see the results. So to run the code at the beginning, maybe you're thinking, oh, it's taking a lot of time. That's because this is the first time that I'm running the notebook. So the first time it has to connect with the server. So that like you're getting, Google is giving you some space. So in that part, you need to wait just for the first time. Okay, so you get the result 50. But if you do it again, it's going to be fast. Yeah, it's faster. So we can keep doing some operations here. Like W equal to x to the power of y. Like basic operations. You can see the W result. And there are some functions that allow you in R. This is an R function that will show you all the objects that you have created so far, like variables, data frames that are available. ls, so it will list all the variables that you have created. So it shows you, okay, you have like a variable w, x, y, and z. All right. So now, remember that you can add more coding blocks. It's not like you have to work only in one. No? You can add multiple coding blocks. And if you notice, it's suggesting, okay, you can generate the code with artificial intelligence. So it depends on the account that you are using. If your account is like a personal account, like at gmail.com, most likely you will see this message here. But if you're using like a private account, from a company or something like that, most likely you won't get this option. It's changing, so I don't know what you will get. All right. So now what we will do is that we're going to create some plots. We're going to generate some random numbers. So in R, to create random numbers is R, that's like random. The name of the distribution, and it's like partially, so it's uniform distribution. So I just have to say the number of numbers, how many numbers you want to create. So let's say 10. That will give me 10 random numbers between 0 and 1, and they are uniformly distributed. So you can increase that. You can do like 100, 1,000, 1 million, right? So we'll do 1,000. So you have 1,000 numbers like randomly generated here. This is useful when you're doing like simulations and things like that. And you can use multiple probability distributions. But now let's see how to plot that. Because you want to, let's say, get a better idea on how it looks, the shape of the distribution of the variable. So let's use a histogram. That will be hist. And here you get in the x-axis, it's the values, right? And in the y-axis, you get the frequency. So I try to be like a rectangle because it's a histogram of a uniform distribution. If not, remember, if you increase the number of observations, then it will be more like a rectangle. Because empirical observations will tend to the theoretical value, right? So that's what we expected. You can improve, of course, your histogram. You can change the labels, the x-axis, even the title. It's called, the parameter is called main. So we can change it. So let me show it to you. I keep forgetting to zoom in. I'm pretty sure I will get an email from you. No, yeah. Okay, so let's call it histogram of uniform data. And that's it. You get the desired plot here. So you can test the random generation numbers. You can change the distributions. You can look it up. It's like random numbers. In R. So you will see how to call the distributions. I know it's RUnif, RNorm for the normal distribution. And you can see the parameters. You will find it. You will find it easily. Let me check RNorm real quick. You have to see the parameters here. Oh, it's norm. That was my mistake. So I guess the default here is, okay, I'm generating 100 numbers. I guess the default is mean, the mean equal to 0, and the standard deviation equal to 1, like the standard normal distribution. But it's possible to change, of course, the mean and the standard deviation value. You need to check just the documentation to check the names of the parameters. But if we change it here, so we can plot the histogram for this one. And of course, we get a different distribution because it's a normal distribution, so it's going to be more like like a bell curve. Again, we can increase the number of observations. So it looks more symmetric, and you know that the mean, the median, the mode is 0 because it's a perfect normal distribution. All right. Let's continue. So here you can check which libraries are available. So if you type library, this function is used when you want to call a specific library, but in this case I want to check which libraries are available here. So it will display the R packages that are available here in Google Colab. If the library is not here, then I will need to install the package. We will do it later. So here you have the list. There is like a description, like what's the purpose of each of those libraries. For example, we will use ggplot2 at some point, I guess in our next lecture. So it says it's to create elegant data visualization. That's true. And yeah, you will see like multiple packages or libraries here, and all of them are useful. All right, so from Some of those libraries, they have specific data sets. So in this case, the good thing about Colab is like it's loading those libraries that I just displayed here to my right. But in general, that won't happen. You need to call the library. You need to load the library so the data is available. So in this specific case, the CO2 library, the CO2 dataset, it's available in a different in the ggplot2 library. So you need to first install it, load it in this case. So it will be available. Again, here in Colab, that was not an issue, but if you're working locally, you need to do this. Okay, now if you want to see like what is this library about, what is this dataset about, so you have multiple options. First, you can visualize it, of course. So it will show you there is a plant, there is a type, treatment, cons, and uptake, but we don't know what is that. So you can ask for help. So with the question mark, it will show you the documentation of this specific dataset, and it says, oh, it's not ggplot2. It's telling me the package is datasets. The package is datasets. So this is the right package, but it's loading that specific dataset. Okay. Then it says the CO2 data has 84 rows, 84 observations, 5 columns, and then it describes each column. So for example, containing the following columns, it says plant and order factor with levels QN1, QN2, QN3. So that's MC1. Then we have the plant. So the options are Quebec, Mississippi. The treatment factor, the levels are non-chill, chill. And the variable con refers to the concentration of carbon dioxide. And we have the units here. And the last variable is the uptake. It's a numeric vector of carbon dioxide uptake rates. And here you have the rates. All right, and then there is more information here, the details, in case you need to know that. But in our case, it's not relevant. I just wanted to show you that typically you will see, you will get like some description of the data sets. So in this case, the one that we were using is just CO2. Now from the same library data sets, I'm going to use a different data set. This one is called Nile. It's a time series, and again we can check what is this data set about. Okay, so it says measurements of the annual flow of the river Nile. So it's just the annual flow. It's a time series. It's the annual flow. So it's some measurement of the flow per year. These are the values that we get, so we can plot them. We can plot and we can visualize the evolution of the flow of that specific river. So there are no more variables here. That's the only variable in the dataset. It's a time series. So now you get to see the time series. So x-axis is the time of the observation. The y-axis is the flow measurement. So you can see if there is a pattern. You can analyze the behavior, and in some cases, like you might draw some conclusions about what is going to be the future values. If you want to predict, once you identify how's the behavior of this time series. All right. So let's keep working with more different data sets. So I will add a different one. There is a package, NLME. It says for linear and nonlinear mixed effects models. And that specific library has a data set called glucose. So what is that data set? So pretty much you have a subject, so I guess that's a person. Then we have time, the concentration of the glucose, and this is the meal, like the time when the person gets a meal. So my understanding is, for example, here 10 a.m. Let's look at the second observation. So it means like time is 0 means like it's like 10 a.m. but this minus 0.25 is like before 10 a.m. and the 0.5 is after 10 a.m. It's to see like if there are some spikes in the glucose when the person is eating a meal. That's like the idea here. So it makes sense. Please notice that before the meal it was like 4.9 the glucose level, like right after, like right during the meal like 4.5, but then right after, time after, it's increasing to 7.84. So that's expected, like you know, it's going to increase because the person just ate something. So it continues during different times, different individuals. So that's the data set. So let's try to visualize this information, but let's use a different plot. So far we have seen histograms, we have seen like lines, but now let's add a box plot. I like box plots because they provide a lot of information. The median, Q1, Q2, Q3, like quartiles. You get to see if there are some, you know, like atypical observations in our data. So they are really useful to visualize our data. All right, so let's create a box plot. So the variables here are, let's focus on the concentration of the glucose. That's our like y variable. And I want to see like how that variable behaves depending on the meal time. All right, so this will be the concentration, that's y, that depends on our x variable here will be meal. I have to let this plot know. If I leave it like that, I will get an error because it won't file. I mean, the R is asking like, okay, what is meal? It's clueless about where to find. So we need to specify, okay, what is the data set? Like those columns exist in which data. So we need to specify that. So data is, in this case, glucose comes from that data set. So now we get our box plot. This is just an EDA, an exploratory data analysis. Even though I can make some hypotheses, I cannot draw like, you know, like conclusions right away. For that you will need like a inferential analysis. So let's see how it looks. So let's focus only initially in one box plot, the first one. So the dark line here, that's the median value. Then you have the whiskers. So if this distance between the whiskers, you know, like the upper and the other one, it's big, it means that you have a lot of variability, right? So for example, at 2 a.m., variability is higher compared to 10 a.m. Now, you will see that there are some points that are outside the whiskers, like in the meals at 6 a.m. and 10 a.m. At 6 a.m. there is like 1 point, and 10 a.m. there are more than one. I don't know how many. Maybe, I don't know, 6? I don't know, because there are some of them that are overlapping in this area. So those are that's outliers. Those are outliers, right? They are not behaving as the other points. So you need to check why it's happening that. So that's part of the EDA. You know, like if you're curious, you can say, okay, I want to see at 10 a.m. I will filter my data. Okay, 10 a.m. Concentration greater than 6, more or less. So you will find those values, or near 8 if you see that. So why that's happening? Maybe those individuals, they had a specific condition, but what it's suggesting is that these points are behaving different to the other points. All right, so we can make comparisons. We can compare the median values. So they tend to be at the same level, most of them. But maybe if you notice 10 p.m. and 2 a.m. they are a little bit like higher than the others. I don't know if the difference is big enough to claim that they are different, but at least from in our plot they are a little bit, you know, like higher, those concentrations. So I don't know. I'm not a doctor, but maybe a hypothesis is like, I think you have heard that, like, okay, you shouldn't eat, you know, like your last meal like very late. Like, you should eat, I don't know, no more than 6 p.m., 7 p.m. So maybe that this is confirming that if you eat like late at night, like 10 p.m. or even 2 a.m., your glucose levels are going to increase more compared to other time periods. I don't know. I'm just kind of like suggesting some hypotheses here, but again, you need to confirm that. This is not science. This is just speculation here, trying to analyze and to make it interesting. Now, what else I can say about this plot? It's not just the median. You can also analyze like variability. So you see 10 a.m. you have fewer variability, but you have a lot of outliers. But again, if you notice 2 a.m. and 10 p.m. they have high variability. So the whiskers are spread. So your observations are more spread. So it's suggesting that you have more uncertainty in the glucose levels in those hours. Why? I don't know the reason, but that's what I see when I'm looking at this plot. So those are the type of questions or hypotheses that you can start asking yourself when you're doing this type of analysis. That's the whole purpose of an EDA, exploratory data analysis. That's why I like these plots, because they give you more information, you know, a lot of information, some statistics. All right, let's move to one more data set, a different data set. In this case, I will need to start to install a package. Let me add some code chunks here. Let's zoom in a little bit. This. Okay. So I'm giving you some time. Here, the library that I'm going to use does not exist. Let me show it to you. So I'm going to try to load it. Library, the name is Palmer Penguins. That's the name of the library. But when I try to get the library, it says there is no package called. In R we call it packages. In Python we call it libraries, but at the end they are pretty much the same thing. So this package does not exist right now here in Colab. So we need to install our package. So let's do that. So let's install. This is the problem with Google Colab. Is that you need, if the package does not exist in Colab, you need to install the package every single session. So for example, we finish the video, you finish your practice, but then tomorrow you wanna kind of review it again, you run the code, tweak it a little bit, but you will notice that the package does not exist. You will need to install it again if you're using Google Colab. But if you are working locally on your desktop, on your laptop, you know you have downloaded RStudio and R. Once you install the package, it's already there. So you just need to call it using library, and that's it. You don't need to install it one more time. All right, so let's install the package. We need to provide the name, Palmer Penguins. So let's install the package. It takes some time. Now it's done. Just 3 seconds. That was fast. So now it's ready. So we can access to our dataset, which is penguins. So it's showing the information. We have the species, the island, and now we have some features of the penguins: bill length, flipper length, body mass, sex, and year. So that's all the information that we have. If you want, you can check the help, you know, the documentation if you want to get more details. But now let's start working with with the information that we have. Okay. So we can use specific variables. Let's say I want to pick this one, build length. Please note that there are some missing observations, like here, for example, missing values. We don't have, for this observation, we don't have that specific variable, and the others. I don't know why. There is like a problem. That's possible in real life. Our data is not perfect, so sometimes that's going to affect our results. So let's check that. So I'm going to access to that specific column. So Penguins dataset, $, and now I can ask for a specific column. So I'm going to use the build length. So I will get just that column, right? And we can kind of like compute some I can try to compute the mean, but it's saying that, oh no, you cannot get it because there are some NAs. So since it's incomplete, you will get the error. I can fix that by adding a parameter here, na.rm, I'm sorry, it's like remove, so I would say true to that parameter to remove the NAs in the calculation. So we'll remove the missing observations. So this one is useful in multiple functions, so you don't get affected by the NAs when you are trying to compute something. Oh, this one is in a different package. So let me see what we have here. Okay, we can check the structure of our variables. In Penguins, for example, we have the species is a factor with 3 levels, island is a factor with 3 levels, then we have the numerical variables, another factor with the sex, and year is an integer value. So with str we can see the structure, and there are other important functions. I remember there is one describe. Let me see if we get it here. Or summary. With the summary we can get descriptive statistics about all variables. This summary is in base R, in the base package. Describe is another package that is not available right now. I can show it to you later which one. But summary, it's always available because it's in the base package of R. All right, so here you get for the numerical variables you will get the minimum value, the maximum value, first quartile, the median, which is Q2, the mean value, of course, max, and the number of missing observations. And for the categorical variables, you get just like the frequency, like number of observations for each level. So this is just to give you a good idea of the information that you have. It's remember the levels of our statistical analysis. So the analysis, the first one is descriptive. This is what we're doing right now. The next one is exploratory data analysis, which is a little bit more interesting. You get to know your data better. And then we have inferential, predictive, and causal analysis. We covered that in our first video. In case you don't know what I'm talking about, we covered that in the first video. And actually, our first homework is about the data analysis types. Okay, let's continue working with the same data set. We can do some plots, like box plot, where we can compare, we can analyze the body mass to see if it has an impact, like if the sex of the penguin matters or not. So let's check that. And get an error because it says couldn't find function box px log, because that does not exist. That was a mistake here. I added an x. It's box plot. then I'm getting another error. It's saying, oh, I couldn't find the object body mass. That's because I'm calling the variable using the wrong name. Because if you notice here is body mass G. So let's do that. Let's modify the name. So we gotta be careful. That's it. But it's good to get these errors so you get familiar on how to handle them. Just read them, you know, like don't be afraid of getting errors when you're coding that. That's normal, it's part of the process. Okay, so now that we have fixed both errors, that I have fixed them because those are my errors, let's analyze our plot. So in the y-axis we have the body mass, and in the x-axis we have sex, female and male. And of course, if you notice here, please check the median value. They tend to be different. So you can say that males are, the body mass is higher, the median appears to be higher, because if you notice here, for female, it's around 3,600, I would say, around 3,600, but for male, it's about 4,000 grams. So it looks like there is a difference right there. But again, this is just an EDA. If you want to make like a formal conclusion, you will need an inferential analysis here. I would say that if you do that, most likely you will find that there is a statistical significant difference. That's my intuition, but yeah, you need to confirm that. So remember, the EDA is where, okay, you get some insight, you understand your data, and you make hypotheses, but you don't confirm those hypotheses. Maybe if there is a huge difference, you know, like something like, for sure it's gonna be, you know, like you can claim, oh, this one is higher, but in general, you gotta be cautious. That's my point. Okay, so let's keep analyzing our variables. So we can use a histogram here to check like the distribution of the body mass. So this is how it works in EDA, guys. You start asking questions, you start, you know, like digging deeper in our data, and we keep extracting some insights. Let's do a histogram. Name of the dataset is penguins. The variable is the body mass. Remember that it has a G at the end of here. So it's not symmetric. It has like a tail that goes to the right. So most values are, you know, like between 3,000 and 5,000 grams. There are some exceptions here, you know, like these are outliers for sure. You know, these penguins here with a body mass greater than 6,000 grams. They are scary, maybe, I don't know. Okay, so I believe that now you get the idea on how to start working and creating your EDAs. We can keep going. We can keep adding more analysis if you want. For example, we can do the same, but for another variable. Let's just tweak it. Let's change it to build length, which we analyzed at the beginning. And the name is, it has two M's at the end. Okay, so in this case, it's more like uniformly distributed in the range between 35 and 50. And then there are some outliers, right? There are like few observations above 52, 53. So you can keep analyzing our variables here. You can start combining the variables in our analysis, finding correlations, heat maps, and different plots. Now, in our next lecture, we will keep working in how to work with data, how to keep performing some exploratory data analysis. We will cover some libraries like ggplot2, where you can get like nicer plots. So that's what we're gonna do. Remember our textbook. The good thing about the textbook for R that we have is that it's free. The online version is free. The authors, they are, you know, like big contributors in the R community. So just go visit the webpage R for Data Science, the second edition. just go for the second edition, and yeah, you will see like all the material that they have. So in our next lecture, we will cover the data visualization. We will start talking about ggplot2. So if you want, I highly recommend you guys to start reading the first unit before our next lecture in the next week. So this is everything for today. I'll see you in our next video.